Hello everyone, good evening. Please confirm that you can hear me. Hello everyone, good evening. Please confirm that you can hear me. Okay, let's begin. Today we'll be talking about batteries. The last time we met, we talked about basic electronics. We talked about some formulas. Then after that, we talked about panels. We talked about wires. We have also mentioned controllers, and I believe you guys have done the assignments. And finally, today we'll be talking about batteries. I don't expect today's lecture to take very long because there's not really much we want to cover on batteries. So let's just get right into it. You already know what a battery is. The main job. Okay, let's talk about why we need a battery in a solar setup. There are basically two reasons why we need battery. Most people think it's just one. There is the popular one for you to store power, right? Battery is supposed to store power, like maybe solar panels will provide energy during the day, and then the battery is supposed to provide the remaining energy at night. But that's not always the case anyway. Um, Most people think solar panels provide energy during the day and battery provide energy during the night. That's not true. Solar panels don't cannot Most solar panels cannot provide all the energy you need during the day, except if you're using hybrid inverter, and even at that you need a lot of solar panels. That brings us to the second use of battery. They support the panel. They support the panel during the day. So batteries support panel during the day. What does that mean? Well, let's look at the mathematics of it. Let's say you have an installation and your panel is 200 watts, 4 pieces of it. That's going to give us 800 watts. And you have your battery, and your battery is a 220 Ah tubular battery. We need to calculate the power that will provide for us, and you know P equals to IV, and the I here is assumed to be 220. We don't really need the time, it's 1 hour. That means it will give us 20 amps in 1 hour. And then the V is 12 volts, and 220 times 12 is going to give us what again? That's 2640, 2460 watts. Now let's say this person is going to be using their laptop, and we assume the laptop is about 80 watts, and they're going to be using phones, and we assume that phone is going to be like let's just assume the total power the person will be needing is going to be, let's assume their total power is going to be 500 watts. Now of course this 800 watts depends on if there is a lot of sun. You don't expect there to be a lot of sun every time. Let's say in the morning, somewhere around 10 o'clock, 100, the panel is giving you half that, which is like 400 watts. That 400 watts is not enough to supply our 500 watt load. That is where the battery comes in. The battery supplements the load. So that is the first. These are three. There are three reasons why we need batteries. The first is to store power. The second is to support the panel, and the third. Let's talk about the third reason why we need. The third reason why we need battery is for their internal resistance. The third reason why we need battery is for load bearing. That's where their internal resistance comes in. You see, when you connect load to directly to a panel, right? When you have panels in the roof, you connect it 100 and they are full 800 watts. Even as they are full 800 watts, they cannot supply a 500 watts load. It's because current in that case, or powering a load, is not a garbage in, garbage out kind of. It's not a garbage in, garbage out kind of scenario where you give me a sec, please. Yes, it's not a garbage in, garbage out kind of scenario where you have 800 watts in your panel, so that 800 should automatically give you the 500 you need. It can supply, it can power the load, but it can't bear the load. You see, when you connect two loads together, their their what's it called now, voltages try to balance each other out, and and that voltage is a function of their internal resistance, because from the popular formula Ohm's law, V equals IR. Load is what is R. Panels are energy sources, so they have a very low value of internal resistance. So when you load them, because they have a very low value of internal resistance, they'll be able to support the 500 watts load. I'm not going to get into the technical explanation. I expect you to go ahead and do that on your own. It's not really assignment, but you should go and learn it, right? When you load a panel, the panel can't support the load because, well, it's not, panels are not meant to power loads directly. They are meant to charge a battery. Batteries have relatively low internal resistance too, so that's why they can easily charge battery. But when you connect your appliances directly to it, these appliances have high internal resistance. So when you connect your appliances directly to them, they won't be able to balance the load. They won't be able to bear the load, so it won't power it. You just see that if you connect a phone to it, it will work fine. But if you connect a fridge to that 800 watt, it will just shut down until you remove it. So the three reasons why we need batteries in a solar setup is: first, to store power; second, support the panel; and third, for load bearing. Let's move on. Well, let's see if we can talk about the chemistry of a battery. I don't think it is necessary for you to know it. The pen is off. I don't think it's necessary for you to know it, but let's just look at it nonetheless. So, battery chemistry. How they work? Well, batteries use the principle called electrolysis. You must have probably done electrolysis in secondary school. And we'll talk about that in our Google Meet. We'll talk about it more in depth there. So, assignment number 1: explain how a battery works with electrolysis. So, that's the first assignment. Well, in electrolysis, you have two conductive, you have the anode, which is positive, and you have the cathode, which is negative. And then you have an electrolyte in between them. Now, the principle of electrolysis: electrons will move from the anode to the cathode. Is it the cathode to the anode? But that's the assignment. Try to explain how electrolysis works for batteries. All right. So let's talk about the difference between a car battery and a solar battery. Sorry, I'm still getting used to the pen of this, what's it called now? I'm getting used to the pen of this tablet, so alright, my handwriting might be a bit uninteresting. So let's talk about the difference between a car and a solar battery. You see, solar batteries are called deep cycle battery. They are called deep cycle, and The other one, which is the car batteries, they are not deep cycle. What's the difference between the both of them? Well, the first thing is in their charging. You see, because solar batteries are deep cycle, they take longer to charge. Typically, you have to charge them from like 10.5 volts all the way to 13 volts. But the other type of battery, which is the car battery, they are designed to charge in a short period of time. Like when you start your car, when the alternator is running, they are designed to charge in that short period of time you're going to be driving for. I mean, you can drive for 2 hours, but the car batteries are designed to be charged really quickly. Another thing that differentiates them is their discharge or depth of discharge, called a DOD. You see, solar batteries are designed to be discharged over a long period of time. They are designed to solve small amount of current over a long period of time. But car batteries are designed to supply large amounts of current over a short period of time. So when you start your car, that cranking, that's when you turn the key, your battery is actually giving you a huge amount of current to start the motors and to ignite the is it 4-stroke or 3 strokes or 2-stroke cylinder operation, the what's it called now? The petrol engine. So it gives you a large amount of current that starts that process. But solar are not designed to work that way. They're designed to give you small amounts of current over a long period of time. If you need more current, you have to buy multiple solar batteries. So you can't use either battery interchangeably. You can't use a solar battery in your car because it will spoil. Because you are loading it too much. You are demanding a lot of power from it in a very short period of time. But the same way you can't use a car battery in a solar setup, because that car battery is not designed to power a fridge for a long period of time. It's designed to just work within a minute or so and stop working. So that is what differentiates solar and car battery. The solar battery is called deep cycle and the car battery is not deep cycle. All right, let's move on. Let's talk about the types of batteries. Sorry, let's use a new page. Let's talk about the types of batteries. Well, there are multiple types of battery anyway. That's your assignment. List all the different types of battery and understand them. That's assignment number 2. But there are two main types of battery that concern us. That is the lead acid. And the second one that concerns us is the lithium. The lead acid battery works by storing charge on a lead plate. So if this is a battery, there will be lead plates all around the battery that store the charge, and then sometimes it will always have an electrolyte, but that electrolyte can be liquid or gel. So that is why we have two main types of lead acid battery. We have the flooded, or we usually call it tubular battery, and then we have the dry cell or the gel type, but we usually just call it dry cell battery. Now you need to understand the difference between these two, the tubular and the dry cell. Oh, just in case you are not familiar with this different battery. What is wrong with? Why is it not searching? So this is a picture of a tubular battery, and then we also have the dry cell type. This is a dry cell battery. This one here. This one here is dry cell battery. So let's move on. Where are we? Okay. We have the tubular and the dry cell. Now the question is, what differentiates tubular battery from dry cell? How do Okay, so let's differentiate tubular and dry cell. Well, tubular battery is flooded, it is wet. The dry cell is it has a gel electrolyte, and tubular batteries has the maintenance stuff. You have to maintain it. You have to make sure the water doesn't evaporate. You keep it away from heat sources so the water doesn't evaporate. By the way, batteries hate heat, so don't ever install solar in a kitchen. You keep it away from heat source so the liquid in it doesn't evaporate. And when the liquid goes below a certain level, especially the red mark, they usually have a tube on top. This will be green and this will be red. So when it goes below the red mark, you have to top it off. You have to top off the electrolytes. And however, the dry cell are also known as SMF. The SMF means sealed maintenance free. They are fully sealed, so they don't really require maintenance like that. That's another reason why people love them. And they're also used in like businesses. When it comes to installing solar for a business, I usually prefer SMF battery to tubular. Also in Nigeria here, although this is not a generally accepted knowledge, but what I've realized that is that in Nigeria here, SMF is usually better because SMF can undo a lot more load. They don't last as long as tubular. Tubular batteries can last 3 to 5 years, but SMF battery usually lasts just 3 years. SMF battery usually lasts just 3 years. They don't last as long as tubular, but they can handle a lot more load. They have higher tolerance than tubular. So for businesses that usually, businesses usually use a lot of electronics. If they're not going to do lithium, we usually install dry cell for them. Especially some of our customers that play games, PS5, we use two of this dry cell battery. Very good one, by the way, very good brand. Instead of using the tubular. The tubular is great. It's great. According to international knowledge, it's supposed to be According to international knowledge, it's supposed to be better, but that's not the case. That's not the case. So that is why we prefer dry cell anyway. Okay. There's also this thing about tubular. It produces gas, right? So sometimes the water in it might bubble, but that's very rare, and it has filters. Like in this tube, there's usually like a black layer of filter that filters out any bad things or any dangerous substance in it. And also, let's talk about the cost. Tubular batteries usually cost around 240K, while dry cell can go all the way to 280K. They're usually more expensive. But again, that's mostly in Nigeria, not abroad. Abroad, tubular batteries are actually the better option. Okay, let's move on. We have just talked about the difference between the tubular and the dry cell battery. And so that is it for lead acid. We'll come back to it shortly, but let's talk about the second one, the lithium. Lithiums are kind of like the best battery for solar. The reason for that is, one, they are lighter. They're lighter because they have higher energy density. Sorry. They have higher energy density. What that means is that if you have two plates of exactly the same size, a lead acid battery might be able to fill 20 into this plate, whereas a lithium-ion battery might be able to fill what's 40%? About 40 into this place. So they have high energy density, which means they can cramp up charge into they can cramp up more charges into the same space. So that's one thing that is great about them. Also, they have longer lifespan. Okay, I don't want to go into these things in depth because we are actually making a video on that. Let me check the scripts of that video, but I'll just give you like a general overview anyway. So lithium-ion batteries are actually preferred, and the best type of lithium-ion, the one we usually focus on. When I say lithium-ion, the best type of lithium, we don't usually use the real lithium-ion. The real lithium-ion it has a lot of problems. What we usually use is the lithium-ion polymer in LiFePo. This is better, it is smaller, and it's a lot less dangerous. It is safe. So assignment number 3, I want you to list the different types of lithium batteries and differentiate them. That is the third assignment. All right, so let's talk about the battery parameters. And before I go again, let me talk about another thing that differentiates lithium from lead, makes lithium actually better. Well, you have the loading, depth of discharge, DOD, depth of discharge. For lead acid battery, that is usually around 50%. Right. So imagine if you are only advised to use your battery from 100 to 50%. Don't use it below 50%. That's how lead acid are. Don't worry, they have already been lower than 50%. But some people use them lower than 50%. And when you do that, you are reducing the lifetime of the battery. They have about 3,000 to 4,000. Sorry, they have about 1,000 cycles. That is the number of times you can charge and discharge them. Let's talk also lithium-ion. Lithium-ion can actually be used all the way to 90% depth of discharge. That's another great thing about them. So let me talk about what I mean again by this depth of discharge. Apart from the using it from 100% to 10% or 100% to 50%, there's also something else I mean by this depth of discharge. Let's say your customer tells you everything they want to power and everything comes up to 500 watts. 500 watts is still okay. Let's use, let's say everything comes up to 1000 watts. Should you use a 220 Ah battery to power it? No, you shouldn't. And here's why. It's not as if the 220 Ah won't power it. If you do the math, calculate the power of this battery. This is a lead acid battery, by the way. 220 times 12 is going to give us what again? You know, the battery, the voltage is 12. 220 times 12 is going to give us 2,640. Okay, sorry. Let's assume this power, the person needs 1,500 watts. Usually, when the power is like this, the person is probably using AC. A 1 horsepower AC will probably take about 1,000 watts. So let's assume the customer wants to power a load of 1,500 watts. And then you shouldn't use one pieces of 220 Ah tubular battery because if you calculate the power rating, the power they can supply, you get this. And please note that batteries also have efficiency. For a lead acid battery, the efficiency is around 65%. 65% efficiency for lead acid battery. So that means we have to calculate 65% of this, multiplying it by 0.65. So that is going to give us 1,716 watts. So you can see now that this 1,500 is already more than 50% of this. If you want to do the math, just take 1,500 divided by 1,716. and multiply it by 100, you will realize that it is more than 50. It is more than 50%. And then you shouldn't load the battery more than 50% for lead acid. But assuming this was a lithium battery, you can still go ahead and power it. It won't last as long. It will probably give you about 1 hour, but you can still power it. It will still work fine because lithium battery allow you to load them up to 90%. So thank you, Edwin. So I've talked about the efficiency value. Very important for me to mention this efficiency value, 65%. So assignment number 4, I want you to figure out the exact efficiency value for lead acid and what's the other one? And lithium batteries. So figure out the exact efficiency value. So whenever you are calculating how long the battery will last, to know the time that the battery will last, you take the power of the battery and you divide it by the power of the load. And don't forget, power of the battery, you need to consider efficiency in power of the battery. So P bat is going to be the rating or the capacity multiplied by the voltage, which is usually 12 volts, multiplied by the efficiency. So you should always consider efficiency in your calculation. That is very, very important. Thank you, motivation, for the 87.4%. So you can see that it is more than that. For blessed Omoleji, you said that is the voltage always 12 volts. Well, it's not always 12 volts. The exact voltage kind of ranges around that, but for calculation purpose, we usually use 12 volts. And yes, actually, most of the battery we use in solar for lead acid is 12 volts, but for lithium, it's not always 12 volts. For lithium, it can come in 12. Multiply that by 2, you have 24. Multiply by 3, you have 36. Multiply by 4, you have 48. But it has to be a multiple of 12. Generally it depends on the inverter ultimately, but we'll get there. Sorry about that. So we have talked about the efficiency. It's a very important part of what we are doing. How many assignments have I given you so far, please? Anybody, please send it to live chat. I want to know how many I've given you so far. Okay, thank you very much, Mr. Tai. Said I've given you 4. That is great. So I want you to another assignment, number 5. I want you to list the different capacity of batteries available for both lithium and lead acid. And for number 6, I want you to go and read on C rate and D rate. By the way, C rate means charging rate and D rate means discharging rate. Some batteries have 1C, which means you can charge them in about 1 hour. I think that's what that means. So I want you to read on it. It's something good for you to know. Anyway. All right. That is 6 now. That's just six assignments so far. So let's do a bit of mathematics. Let's calculate how long a battery, a 200 Ah dry cell battery, is going to last if it's powering a 300 watts load. In that case, we need to first calculate P bat. P bat is going to be the capacity times the voltage times the efficiency. So that's going to give us 200 times 12 times 0.65. That's 2,400 times. Am I correct? 200 times 12 times 0.65. So that's going to give us 1560 watts. Thank you, Edwin. So the P load, we already know that the P load is 300 watts. So that means it is going to last 1560 divided by 300, and that is going to give us so we expect this to last 5.2 hours. We expect the set up to last 5.2 hours on such a battery. Of course, you need to consider another thing, and that is the panel. If this calculation were made during the day, you need to consider the effect of the panel on the calculation. And let's quickly do something similar to that now. Let's do a math where we have 400 watt solar panel and we want to charge a 200 Ah battery. How long is it going to last, and will it charge? Those are the two questions I'm asking. First, how long will it last? And the second question is, will it actually charge? You need to be able to answer the two questions. Let's quickly do that. Well, for this calculating charge time, you use P battery. You calculate the P bat and you divide it by the P panel. However, in this calculation, you don't consider efficiency for the battery part. It's very, very important that you note that when calculating discharge time, you consider efficiency of the battery. But when calculating charge time, efficiency does not matter. So P bat is now going to be 200 times 12, but we're not going to add efficiency, which is going to give us 2,400 watts. Don't worry, I'm going to get used to this pen. So P panel is 400 watts. So that means the charge time, let me just call it CT. How long it is going to take to charge will be 2,400 divided by 400, which is going to give us what now? 6 hours. So that brings us to the question, will charge? 6 hours. Well, thank you, Edwin. I love that. Thank you. Well, it will charge, but not fully. It won't fully charge. Why is that? Well, Nigeria gets about 5 hours of sunlight. Some people say it's 5.2 hours of sunlight per day. So we get about 5.2 hours of sunlight per day, which means that it won't charge for two reasons. Assume that the person is not even using their solar at all. At the end of the day, it will not charge because it needs 6 hours to charge, and we only have 5.2 hours of sunlight. That's the first reason why it will not charge. The second reason why it will not charge is, of course, the person will be using their solar during the day. You don't expect them not to use their solar during the day, which means if they are using it, part of the 400 watts that's supposed to be coming from the panel will be going to their house to use their load, which means by the end of the day, the person might end up with about 30% or 40% battery charge at night. Okay, let's talk about the solution. Yeah, thank you, Edwin. It's not a good system because sunlight doesn't go for 6 hours a day. The solution is more panel. That is it, more panel. But let's talk about how to determine the number of panels to use for a particular battery. You know what, Edwin? Let's take a step back. Let's talk about how to determine the battery to use in the first place. Point number one, determining the battery to use in the first place. Well, you need to first know all the loads the person will be using. Then determine the type of battery. Either you're going to be using a lead acid battery, which is either tubular or dry cell. You also determine whether to use tubular or dry cell. We'll get into how you do that now. CT is charged. Please keep up, please. Or you're going to use a lithium battery. Either you're going to use I've been distracted. Okay, yes. You need to determine. Let's determine how many batteries we're going to use, or the rating of the battery we're going to use. The first thing you need to do is to determine the load the person will be using. Determine the total load. Ask them, what are you going to power? So by knowing what their power, you can estimate the total load. So let's say we estimate that the person is going to use a 500 watt load in total. Maybe this 500 watts is probably 100 watt from or 200 watt from 2 laptops and then fan and light and everything is going to give the remaining 300 watts. We just assume that the person is going to need 500 watts of supply. We have determined that the person will need 500 watts of supply. Well, what this tells us is point number one. We need to get an inverter whose rating is more than 500 watts. Although we're treating inverter today, but I just need to mention it. We have reached system design. Pay attention. This is what solar is all about, determining what to use for your installation. We have determined that the person's load is 500 watts. For us to power this load, we need to use an inverter whose rating is more than 500 watts, but it is at least 500 watts more than 500 watts. Let me explain. You need to find an inverter whose rating that if you find 80% of the rating of that inverter, it is going to be more than or equal to the load you want to use. Let me show you an example. Let's say we use a 600 watt inverter. This is not recommended. Why is that? 80% of 600 watts is going to give us what? It's going to give us 480 watts, which means the true power, we assume true power is going to be around 480 watts, and that's even if it's a good inverter. And that 480 watts is not enough for our 500 watts. By the way, you can't even find 600 watt inverter. So the next best thing is a 1000 watt inverter, which we know that is going to power this load. You have determined the inverter you're going to use. Fine. Let's talk about how to determine the battery. You need to decide, am I using a lead acid battery or a lithium-ion battery? If you are using a lead acid, by the way, LA means lead acid battery. If you are using a lead acid battery, then you need to consider what I told you about loading percentage. I told you that for a lead acid battery, you should never load it more than 50%. I also told you that for a lithium-ion battery, you can load it up to 90%, but try to keep it away from 90% as much as you can. So, which one are we using? It depends on the customer. Lead acid batteries are usually cheaper than lithium-ion batteries. So, if the person is on a low budget, use the lead acid. But if the person can afford it, use lithium-ion battery. So let's assume we are choosing a lead acid battery, which means we want to find a battery whose rating is 2 times the power rating that the person needs. 2 times is basically like saying 50%. You know what I mean by that. So 2 times 500 watts is going to give us what? Or better still, let's do it this way. List the rating of the available rating of this that you know. We know that we have 40 Ah battery. We have 40 Ah battery. We have 75 Ah battery. We have 100 Ah battery. We have 200 Ah battery. By the way, there's 180, 130 now. They're basically 100, just people trying to make more money. We have 220 Ah battery, and so on and so forth. This is one of the assignments, by the way. I think that was assignment number 3 or so. So, how much power will 40 Ah battery give us? That's 40 times 12. And multiply that by the efficiency, 65%. It's going to give us 312 watts, which is not enough to power our load. And if you were to calculate 50% of 312, you're going to have what? You're going to have about 150 watts, which is way less than what we need. Let's try 75 Ah. So 75 times 12 times 0.65 is going to give us 585 watts. Let's not waste time on this 585 watts. I mean, 50% of 585 watts is about 270 watts. It's not up to the, what's it called now? 500 watts that we need. Let's try 100 Ah. 100 times 12 times 0.65 is going to give us 780 watts. 780 watts. Fine. 50% of 780 watts. Now, I want you to note something before I continue. This 780 watts is more than the 500 watt. It will work. But for a good installation that you want to last, you should not use 780 watts. 780 watts, 50% of that is going to give us what? For around 350 watts or so, which is still less than what we need. So let's try 200 watts. 200 times 12 times 0.65 is going to give us 1560 watts. 50% of that is going to give us what? 780 watts, which is more than 500 watts. So we have a winner. We can use a 200 watt battery, just one 200 watt battery for this. Now, this is still stage 2. Before you move to stage 3 and determine the panel you use to charge this battery, you need to determine another thing. You need to ask yourself, how long do I want this solar to last for at night? How long do I want it to last for at night? Well, me, I usually target 6 hours, right? So I usually target 6 hours because I want to satisfy the customer. But this customer in this case, well, this person has 780 watts of power. 780 watts of power. And they want to power 500 watts, which means they will only get about 1.5 hours. They will only get 1.5 hours of power, which is not a lot, by the way. This is the kind of installation that you do that the customer will start complaining to you that the solar doesn't last. So this is not good. But what if we are to use 2 batteries, 2 pieces of this 200 watts, where you can multiply this by 2, and it is going to give you, when you multiply this by 2, it will give you 3.12 hours, which means it will last 3 hours. Well, that's still good. So if your customer can afford 2 batteries, that's fine. And even if they can afford 4 batteries, it would be great, because with 4 batteries, you'll be able to have about 6.24 hours, which is the ideal stuff that I usually target, because people usually use their solar up to 12 o'clock midnight. So when I tell someone something lasts 24/7, I only mean from morning to 12 midnight. Most people don't use solar in the middle of the night. Most people don't. So 4 batteries is what we really need, but of course, it depends on your customer's budget. If your customer can only afford 1 battery, you go for it and you let them understand that they are 500 watts. They should use it during the day. They should use most of the heavy things during the day. Once it's night, they should minimize usage. Maybe use only 1 laptop, turn off the light, use fan. Don't turn on the light of the kitchen if you are not in the kitchen. So those are the kind of things you need to tell your customer. Because we went to install something at Ibadan last week or 2 weeks ago, and we used 1 battery, and the person wanted to use PS5. I already told him from the beginning it will not work. So he said he will manage it. The next day he called me. We had to go back like after 3 days to go and add another battery and more panels and so on. So that's the thing. You need to do this formula, this equation, understand how long the solar is going to work, and advise the customer. If they still insist on using 1 battery, you let them understand that you don't expect them to use the full 500 watts at night if they want to get more hours. So now that you have determined the number of battery you want to use, let's just assume we are using let's assume we're using 1 pieces of 200 AH battery. Next, we need to determine the panel that we're going to use. Edwin is saying, wow, all the way to Ibadan. That's funny. That's not distance. When you do solar, it takes you multiple places: Abuja, Lagos, and so on and so forth. Even there was a job we were supposed to go and do in Akwa Ibom recently. We are reconsidering it, but that's the way it works in our line of job. It takes you multiple places. But hopefully, for those of you that perform excellently well in this program, we're going to select about 5 of you or 10 of you. And once we have awarded you the certificates, we'll be you'll be able to freelance for us. So let's say we have a job in Akure and we're no longer based in Akure, or we are not available for job. Because we have trained you, we'll pay you to do the job. That's the way the freelance works. So please try to be engaging, try to show us that you can do it. So let's move on. We have determined we're going to use one pieces of 200 AH battery. Next, we need to determine the number of panels we need to charge this 200 AH battery. So the question you need to ask yourself 3 questions. Question number 1: how long do I need it to last? How long should the charging take? How long do I expect the battery to charge for? Well, in answering these questions, you need to know that no matter how long you come up with, it must always be less than 5.2 hours, because that's what you have for the day, 5.2 hours of sunlight. But apart from that, you also need to consider another question. The second question you need to consider is daytime usage. If you design your solar panel to charge your battery in 5 hours, it will not charge it in 5 hours because the person will be using it during the day. So part of the panel power that's supposed to go to the battery will go and power the person's house. So that is another issue. You need to consider that. Typically, we used to we put the charge time at 3 hours. That's what we target for a budget customer. But for a customer that can afford it, we put the charge time at 2 hours. 2 hours is a better option, but 3 hours is also moderate. It's okay. We target that. But don't target 1 hour or 30 minutes, except if you have a good controller. If you're using a PWM controller and you target 1 hour's charging time, your battery is going to start spilling water all over the place. That's why some people say that their battery is leaking. It's not actually leaking. It's because it's charging so fast that there's a lot of bubbles forming up in the tubular battery, and with that number of bubbles, the water is going to rise up and start spilling all over the place. It's even better if it's tubular, because if it's dry cell, it will just explode. Of course, it won't explode. I already told you the last time that dry cell batteries have things like tubes on them that will pop up, and that can still be dangerous. So, target 3 hours. Now, let's determine the number of panels. To know the number of panels, or before we do that, to know the panels you need to calculate the power of the panels. To know the power of the panels you are going to need, you need to take the power of the battery and you need to divide that by the charge time you are targeting. So how do we calculate the power of battery again? It's going to be the capacity of the battery, which in this case is 200 amps, times the voltage. Remember, in calculating charge time, you don't include efficiency. So this is going to be 2400 watts. So the power of the panel is now going to be 2400 watts divided by our target, which is 3 hours. So 2400 divided by 3 hours is what? Well, that is 800 watts. Now, you need 800 watts of panel. Of course, from your last assignment, one assignment I gave you then, I asked you to list all the capacity of panels. You probably didn't see anything like 800 watt panel. It doesn't really exist. So, of course, we can use things like, now pay attention to what I'm about to say. We can use 400 watt panels times 2. We can do that. It's a good idea. But there's something wrong with this. Let me explain. What is wrong with using 400 watt panel times 2 pieces of 400 watt panels? It's going to work. It's still the same 800 watts. But the main issue with it is your controller. A customer that could not afford 4 batteries or 2 batteries, that told you to use 1 battery, will probably not be able to afford an MPPT controller, which means you will probably be using a PWM controller. Oh, yeah, that reminds me. we need to, after this, we'll figure out the rating of the controller. But you know that the person will be using PWM because the person couldn't afford multiple batteries, right? If the person can afford an MPPT, go for it. But the person will most probably going to be using a PWM controller. So that means that we need the voltage of the panel to be insanely close to the voltage of the battery, or else we're going to have excess voltage, and excess voltage means waste of power. Remember our last lecture. Which means we are going to be using a PWM controller, and a 400 watt panel is like 36 volts. And you know that 36 volts in reality is almost like 45 volts, and we only have a 12 volt panel, which means you'll be wasting about what's this, 33 volts, which is more than 50% of what you have. In essence, if you use two pieces of 400 watts panel on a PWM controller to charge a 12 volt battery, you will end up with just 200 watts total. Imagine, from 800 watts all the way to 200 watts. It's because of this that people will start telling you, my battery is not charging. Hello, Oga Solar, you have done fake thing for me, my battery is not charging. You'll be wondering, 400 watts, 400 watts, it's 800 watts. According to the formula Mr. Daniel told us, this thing is supposed to work now, it's supposed to charge in 3 hours, it will not charge. The reason why it will not charge is because you're using a PWM controller. So, see the way I'm talking as if I'm preaching. So if you're using a PWM controller, you need the voltage of the panel to be insanely the voltage of the battery. So we need to use a 12 volt panel. If we're going to use a 12 volt panel and we want to achieve 800 watts, who can quickly tell me what we should do in the live chat section? Anyone, please, very quickly. We have a lot to cover and there's not a lot of time remaining. Who can tell me what to do? We need 800 watts. My first idea was for us to use two pieces of 400 watts. The reason why that idea failed is because we will never achieve that 800 watts. The max we'll get is 200 watts because we'll be wasting about 33 volts of power. So who can tell me what to do, what the solution is for us to achieve our 800 watts without wasting too much power? You know what, we don't have time. Let me just go ahead and answer it. We need a 12 volt panel, and the max 12 volt panel we can get is 220 watt. God bless you, Mr. Fatai. That's the correct answer. We need a 12 volt. Thank you, Edwin. We need a 12 volt panel, and the max 12 volt panel is probably 200 watts. So multiply that by 4, we have 800 watts. So, ladies and gentlemen, we have determined the inverter, we have determined the battery, we have just determined the panel, we have also determined the number of panels to use and the rating of the panel. You can see that all these things within solar, they are not guesswork. They are calculated things. The moment you start guessing, you start having problem. And let me tell you something. No, you should not double the controller. With that, AB Tech, you don't double controller. You will get to controller shortly, don't worry. Problem in solar costs a lot of money. A mistake in solar can cost you 500k. It's not something that will cost you 20k. There's no 20k mistake in solar. There's no 50k mistake in solar. The smallest mistake in solar you can make will probably cost you 150k. So let's get that. Yeah, Mr. Fatai. Question number 2. Mr. Fatai just gave me a question I like. These 4 panels, how do we connect them? Parallel or series? To answer that question, we need to remember why we are even using this panel in the first place. We're using this panel and we're using a PWM controller. And you know, PWM controller, the voltage of the panel must be very close to the voltage of the battery, which means that we need to connect them in parallel, not series. If you connect them in series, you add up voltage, current remains the same. If you connect them in parallel, you add up current, voltage remains the same. So parallel connection is what we are going to do. Yeah. Thank you very much, Mr. Vatai. I really appreciate you pointing that out. Forward to seeing more of you, Mr. Vatai. I really love the way you You understand this thing. So let's move on. We have determined the number of panels. We have determined how the panel should be connected. Let's determine the wire. Let's determine the wire. There is one main thing that determines the wire you are to use in solar, and that thing is current. Current is what we need to determine wire. Now, we have an 800 watt panel system that is supposed to be supplying us that 800 watts at 12 volts. The mathematical thing for us to calculate current is to take power divided by voltage, because remember, power is IV. So I is supposed to be 800 divided by 12, which is supposed to give us, what's that now? It's supposed to give us 66 watts. Well, this is all sweet and good, but let me tell you, you will not get 66 watts. That's not possible. The reason why it's not possible of your panel, you can already estimate the current you're going to get from the panel, right? This is the mathematical way to do it, but this is not how we do it in the field. From the rating, from what we have known from experience about panels, we know that the maximum our 200 watts panel are going to be able to give us is 10 amps. Now, if you multiply that 10 amps by 4, the maximum you probably get is 40 amps. So we need a wire whose current tolerance is much more than 40 amps. So we probably need a wire who can handle up to like 50 or 60 amps. In that case, we can use a 4mm. No, a 4mm is not good. 4mm is about 40 to 50 watts. I've seen it get hot sometimes. Sometimes when I use 4mm, after a while, during dry season, it will start getting hot and it's not very good. So we use a 6mm cable. By the way, it should be a DC cable, and by the way, it should be flex. Don't use single core, because this is current low voltage system. If it was to be series connection and MPPT controller, you can probably use single core, though you should always use flex, but I'm telling you because of what we said in the last class. So we have determined that we are targeting 40 amps of current. Let's move on to charge controller. What determines the charge controller we're going to use in our what's it called now? In our system? Well, what determines it is the current coming from the panel. We have calculated that 40 amp current will probably, because we have calculated that, we need a controller which is more than the panel current. So we can use, and it needs to be much more. You know what I told you the last class? If you need a 30 amps controller, buy a 60 amps controller. Controllers are fake. Most of the controllers we have in the market, their rating is not really what it is said to be. So you can use a 60 amps controller in your system, a 60 amps PWM controller. You can use a 60 amps, it will work fine. But if you want to be cautious, probably use 80 amps. If you want to be cautious, probably use 80 amps or 100 amps controller to power your stuff. So, ladies and gentlemen, we have talked about the load, the inverter, the panel, the wire, the controller. We have talked about the battery. I think we have achieved something today. So let me just close up by saying a few things, some other thing about battery before we move on. Oh, will you look at that? I think that's probably everything we need to talk about. Let me send the attendance link. If you have any question or comment, this is the time to send it. So I've sent the attendance link. Please confirm that you have been able to gain access to it. Once anyone has been able to fill it, please send a message to the chat that you have been able to fill it. And if you have any question, this is the time to ask. Oh, yes, before I forget, one more thing. One more to add to your assignment. How many assignments have I given so far, please? Yeah, thank you, Mr. Fatai. How many assignments have I given so far? 6. Are you sure it's 6? I think it should be more than 6. Oh, yeah, sorry. The part I put as answer should be what you learned today. It should be what you learned today, not answer. I've changed that. But please, how many assignments have I given so far? Okay. So we'll go with 6 then. That's good. 6. And one more assignment. Design a solar system. Just design it. Assume a load capacity and design the rest of the system. Talk about every single thing. The inverter, the panel, wire, the controller, the battery. Talk about everything. So make sure you explain it very well, please. That's what will determine the mark you're going to get. Don't forget, attendance, assignment, the test is going to contribute greatly to your final grade, and you need 70% to even pass at all. And also engaging with us on social media can add 10 to that, although it's not officially part of the grading, but it can help. So we have reached the end of today's lecture. It's been a pleasure. Thank you for being with us. Thank you for following us. Don't forget to follow the page, follow the channel. We are going to be posting a lot more videos soon that you are going to enjoy a lot. Don't worry. Good night, everyone. Okay, wait. Is there a software to design, or it should design stating it? Oh no, just write it out. Don't do it with software. And if you feel like you can design it with Paint or software, you can do that. But I want you to write it out, type it out. Right. So good night, everyone. Let's go to the group and have a little bit of chat.